All right, hello everyone. This is the first part of the video for section 1.6, our last section for chapter 1. Can't believe we're already there. Time flies when you're having fun, right? Okay, so let's jump into it then. Section 1.6. So we're going to start talking about what are called inverse functions. Okay, and here's how this works. So let's suppose we have a function f where we have some input a that gives us an output of b. Then we call a function g the inverse of f if g of b equals a. And so notice what we've done from the function f to the function g there, and in particular, what have we done with the inputs and the outputs? Right, it looks like they got switched, right? In function f, a was an input and b was an output. In the function g, b is the input and a is the output, so they switch roles. Okay, so a function, an inverse is really a function that takes and switches the inputs and outputs of a function. Okay, and usually when we're talking about the inverse of a function, we don't give it a different name like g. What we do instead is use this notation that kind of looks like the function with an exponent of -1. Okay, and be very careful, because something like this, f inverse of x, which is how that's read, is different than something like 5 to the -1. Okay, 5 to the -1 means to do a reciprocal and give something like 1/5. The f with the -1 does not mean the same thing. That does not mean like 1 over f of x. Okay, those two things are not the same. All right, and so if we use that notation for inverses, then as you notice there in the definition, they say something like, if we have f of a equals b, so there a is the input and b is the output, then for the inverse function using that notation, now b becomes the input and a becomes the corresponding output. All right, so let's look at using this to find the inverse of a function from a table. Okay, so here we have a function f, and notice there in the top row they've got the inputs for that function, whoops, and on the bottom they have the outputs. Okay, and we're asked to first of all create a table for the function f inverse. All right, well, let's go ahead and do that. So I'll draw my table here. It's going to have 5 spots. Okay. And even though we're switching the inputs and the outputs here, as far as what goes in this first column here is we're still going to use x as our input variable. And then as we talked about for the inverse, we use this f with the -1. But then as far as what goes in the table, we follow what I just said a second ago. So now all of these outputs here, the 3, 5, 7, 9, 11, those will become the inputs of this inverse function. And then all of those inputs from up above, 1, 2, 3, 4, 5, those become the outputs down here. Okay, so now we have a table for the function f inverse. And what we can do with that now is evaluate the inverse at some different values. So for the first one here, notice we've got f inverse of 3. So looking at our table, looks like if we input 3 in the inverse, we get an output of 1, which if we correspond there, compare that with the original function, right, that corresponds to right here. 3 was an output for the original function, so as an input for the inverse. So the output for the inverse is the input for the original function. Okay, f inverse of 5, that's going to be our second one right here. So if we input 5 to the inverse, we get an output of 2. And then now for the third one, we have f inverse of x equals 3. And recall that when we see this, in this case now, this 3 is an output for our inverse function. So we're looking at, whoops, sorry about that, hit the wrong button. We're now looking at where 3 is the output, which is right here, and so we're trying to find the input, and looks like that is at x equals 7. Okay. Recall there we wrote x equals 7, not f of 7, or excuse me, f inverse of 7. We wrote x equals 7 because we were trying to find the input. Similarly, we're here and we're trying to find the, we have f inverse of x equals 5. We need to solve that. Well, that's where the output value is equal to 5, which is right here. And so we see that corresponds to an input of x equals 11. Okay, so that is using inverses with tables. Let's now look at using inverses with graphs. So here we're given a graph of the function f of x, and we need to evaluate and solve the following that involve f inverse. Okay, so we have to be careful about how we do this. So f inverse of 3. So here we're trying to input 3 into the inverse function. Well, again, as we're talking about, inverse functions switch the inputs and the outputs. So this 3 is an input for the inverse function. For the original function, f is actually going to be an output, which means it's going to be this 3 here on the vertical axis. And what we need to figure out is what is the input that is related to that. So to figure that, we go over to the graph. We see that it corresponds to this point, which then corresponds down to this input value. So we see that f inverse of 3 equals 1. Okay, and again, the reason for that is for the original function f, 3 is the output, and we had to find the corresponding input. Whew, a lot going on there, right? Okay, next one then, we need to solve f inverse of x equals 4. Which here now they've given us an output for the function f inverse, but an output for f inverse would be an input for the original function, right? So what we'll do is on our function f over here, go over to 4 on the horizontal axis because we know that's where the inputs are. Go up to the graph, see that it corresponds to this point, and then go over and see that the corresponding output there is 2. So the input for the inverse function would be x equals 2 there, okay? All right, and again, that's because 4 output for the inverse function, so an input for the original function, we had to find the corresponding output from the original function. Okay, and that's where I want to leave it for now. Thank you for watching.